Hello everyone, this is a review for the atomic structure. So let's get started immediately. First question, what are the three main subatomic particles? So that's so easy, as you know that subatomic particles exist in an atom. So there are three of them: protons, electrons, and the neutrons. Okay. What are protons, neutrons, and electrons found in? Where are protons, neutrons, and electrons found in an atom? Okay. So protons and neutrons exist in the nucleus of an atom. Okay. While electrons exist outside the nucleus. Okay. So let's highlight this. Protons and neutrons exist in the nucleus, while electrons exist outside the nucleus. What are the charge of the relative mass? What is the charge and relative mass of a proton, electron, neutron, and electron? Okay, that's so easy because the proton is actually has a charge of +1. Okay, the proton has a charge of +1, and the mass equals 1. Okay, the neutron has 0 charge, okay, and the mass equals 1. An electron has a charge of -1, and the mass is very, very small. It's 1/1840. So this, we call this negligible or neglected mass of electron because it's very, very small. An atom of sodium has atomic number 11 and mass number of 23. Okay, so this is the atomic number and this is the mass number. How can we get the number of protons, neutrons, and electrons? Okay, so focus at this, guys. Okay, focus at this part here. The atomic number is actually the number of protons. Okay, so how many protons does it have? It's 11 protons, as the atomic number is 11. How many neutrons does it have? In order to get the number of neutrons, just subtract the atomic mass minus the atomic number, and it is 12. The number of neutrons in this atom is 12 neutron. The number of electrons in any neutral atom, the number of electrons equals the number of protons. Okay. Explain the difference between atomic number and mass number. Okay. Actually, the atomic number is the number of protons. Okay, number of protons. This is the atomic number. While the mass number is the sum. Let's the sum protons plus neutrons. Okay, this is the mass number. Okay, so the atomic number is the number of protons, positive protons, while the mass number is the number of protons plus the number of neutrons in the nucleus. Define the term isotope. Actually, isotopes are the elements of same type of atoms which have the same number of protons and electrons, of course, but different number of neutrons. Okay, so they will have the same atomic number but different the elements. Okay, elements of same type of atoms which have the same number of protons but different number of neutrons. Okay, so you can see here this isotope of chlorine has two isotopes, Cl35 and Cl37. In this case, guys, you should be aware that we write down the name of the isotope with referring to the mass number. Okay, so the mass number of the first isotope of chlorine is 35 and the mass number of the second isotope of chlorine is 37. Why we write it down in mass number? Because the atomic number is the same. Chlorine has atomic number of 17, and this isotope has, because they have the same number of protons, so they are similar. Okay, so we write down the name of isotope by its mass number. Okay, so the question asks you, how are they similar? They similar because they have same identity, right? Identity, I mean the same number of protons. As I told you before, guys, the number of protons in any atom, the number of protons in any atom represent the identity of the element. Okay, so this is chlorine and this is chlorine. They have the same identity, but they have they have the same protons. And how they are different? Because they have this, they have different number of different number of neutrons, which make them have different number of masses. Okay, give one medical use of isotope. So in one medical use of isotope, we can see we can say that actually there are a lot. Okay, let's try one of them. Yeah, we can say the cobalt 60 is used in cancer treatment. Okay, the cancer treatment, this one we call it radiotherapy. We call it radiotherapy, which means radiotherapy mean the therapy using radiation. Okay, therapy means like treatment. Okay, radiotherapy using radiations. So the radioactive elements like the cobalt 60 is used in cancer treatment. Give one industrial use of isotope. One industrial use. Okay, we can say we can use the isotopes as tracers. Okay, to detect leaks in underground pipes. Okay, because they are radioactive again, so we can use them as tracers. Okay, to detect the leaks in any underground pipes because of their radiation. Okay, state whether isotopes of the same element have the same chemical properties of different chemical different chemical properties. Explain and answer. So as we explained in the class before, that isotopes of the same element, they are actually having the same number of protons and electrons, so they have the same chemical properties. Okay, so I will say at the beginning they have the same chemical properties. Why? As they have same number of electrons. I have in any chemical behavior, we refer to the number of electrons, not the number of protons. Okay, they have the same number of electrons, because the behavior of any chemical atom in chemical reaction is actually depending on the number of electrons exist in that atom. So carbon 12 has how many protons? It has 12 protons. It has 6 protons. Because this is the mass number, it has 6 protons, 6 neutrons, and 6 electrons. The carbon 14 has 6 protons, 8 neutrons, and 6 electrons. So how did I do that? As I told you, the carbon 12 and carbon 14, this is the mass number. If you review the periodic table, okay, you can find that carbon actually has an atomic number of 6. Okay, so it means that it has 6 protons. So both has 6 protons, and the number of neutrons we subtract. 12 minus 6 is 6, 14 minus 6 is 8, and of course the 6 electrons are the same as the number of protons. Okay. Relative atomic mass. In the relative atomic mass, we take this relative atomic mass from the isotopes and their abundancy in nature. Okay, so the question here asks you to define the term relative atomic mass. Actually, the relative atomic mass is the weighted average mass of the isotopes of an element. Okay, this is the and also I want to add another part taken in consideration the abundancy of both. Okay, because we take consideration the abundancy of both. Okay, and you will understand what I mean here, because we will always multiply by the abundancy, the percentage of the existence of that element in nature. Okay, so the element X has two isotopes, 80% X2 20 and 20% X22. Okay, so in this case, in order to calculate the relative atomic mass of element X, I'm gonna say that AR of the element X equals 80, the first percentage, multiplied by the mass number, which is 20, plus the percentage of the second one, which is 20%, multiplied by the mass number of the second element, which is 22, and you divide this by 100. Okay, so let's write this down on the calculator. $80 multiplied by 20 plus 20 multiplied by 22. So this is the total of them. Divide this by 100. So it equals 20.4. Okay, so the relative atomic mass here equals 20.4 AMU, the atomic mass unit. Okay, guys. Neon has 3 isotopes and it is given information. Calculate the relative atomic mass. Again, so the AR of neon equals the first percentage, 90%, multiplies by 20, plus the second percent, which is 9%, multiplied by 21, plus the third percentage, which is 1%, multiplied by 22, divided by 100. You can work this out and you will find that the on the calculator, and you can find that this is actually equals to 21 AMU atomic mass unit. Okay, this is the final answer. Okay, guys. Why is relative atomic mass of chlorine not a whole number? If we check the periodic table, the atomic mass of chlorine 35.5, and it's telling you why. Why is it not a whole number? Not a whole number because this is an average, right? As we said before, because this is the relative atomic mass written in the periodic table. This is the relative atomic mass written, and we can say here the same definition. Okay, because it's the weighted average mass. Let's write it down again. I was going to copy paste it, but we can write it down again. It's not a whole number because it is an average of the isotopes of chlorine masses. Okay, it's an average the mass of chlorine's masses. Okay. An element has isotopes with mass number 10 and 11, the relative atomic mass 10.8. Which isotope is more abundant? So that is very, very like tricky question. We said that the relative atomic mass equals relative atomic mass, the relative atomic mass AR equals the first element multiplied by its percentage plus the second multiplied by its percentage divided by 100, right? We can do this on the calculator and solve them for x. How can we do this? The AR is given, it's 10.8 equals, okay? The first isotope, the mass number is 10 and it is multiplied to a percentage. Let's leave this to the end, I will explain. The second is 11 and it is multiplied to another percentage.